Right, so today we're going to look at section 1.4, which is on solving equations with absolute value. Okay, big thing that's going to happen in this section is usually you're going to get 2 answers per problem. 2. All right. Most of the problems we've done so far, you only had 1. Okay, but most of these, not all of them, but like 90% of them are going to have 2 answers. And I'll show you how you can tell. All right, you got to be able to tell, does it have 2 answers or is it something different? All right, so if you want to write absolute values, anybody remember the symbol? There's a special symbol we use in math for absolute value. Lucas?
It's not kind of like a bracket, but it's like more more square.
Okay, it's simpler than a bracket. Kind of looks like a bracket, but just 2 vertical lines.
Sorry.
Okay, just like that.
Someone had to say.
How many people have seen that before? Yeah. Okay. So when you put bars around something, that's called absolute value, right? All we're going to do today is we're going to put that into an equation and solve it. So how would you write, if they asked you to do this, how would you write absolute value of 4? Just like on paper. Yep.
You just put the 2 lines and the 4 inside of it?
Yep, exactly. Whatever you want to take the absolute value of, you just put it inside the bars. Okay, so in this case, 4. So does anyone know what absolute value means? It actually measures something about a number. If you want to think of it as like on a number line, it measures something about it. It's kind of like length from a certain spot. Yeah?
The distance a number is from 0.
Yeah. So on your guided notes where it says absolute value measures, and the key thing is it measures the distance from 0. Distance from 0. So what do you think that means about absolute value? If it measures distance, distances can only be what kind of numbers?
Positive.
Positive, right? Distances can only be positive. So anything that you put inside these bars automatically turns positive, right? So if you put in something like this, absolute value of -3, if you think of it on a number line, you're right here. How far is that dot from 0?
3. No.
I said
3. Yeah, it's 3. Right? It's 3 units away because it's absolute value and it's distance, which always makes it positive.
Wait, so if it was like the -3 and the absolute value, wouldn't that make it positive?
That would make it positive. So, an equation that has absolute value in it is just called an absolute value equation. All right. So that I'm just writing that part on the board. Then I think the next part you guys are going to write down. Okay, how to solve an absolute value equation. And I told you that too. So absolute value equations, like 90% of the time, is going to have 2 solutions. Okay. It is possible that you get an absolute value problem that only has 1 answer. That's just like the problems we've done all year so far. But you can also get an absolute value problem that has no answers. Right? So out of these 3 different things that can happen, I'll probably pick a couple of them and put them on the test. Okay? Most of the problems are going to be these 2 solutions. But you might get one that's a 0 solution. Or a 1 solution. And I'll show you how you know. Okay, when you solve it, you'll know. Okay, so the first thing when we're solving an absolute value equation, it says ensure this. Ensure that the absolute value expression, that's basically the thing in the bars, is by itself. Okay, the absolute value expression has to be by itself. And that'll be on one side of the equal sign. It could be on the left, it could be on the right. I usually put it on the left. But it's kind of like when you have a distributive property. It could be on the left, it could be on the right. It doesn't really matter. And I'm going to show you guys what that means. Okay, I'll show you a problem where the absolute value is by itself, and then I'll show you one where it isn't. Now, if it isn't by itself, okay, we have to ensure that it is. We have to get it alone. So there's two things that could happen. All right, and I'm going to show you what they are. So if there is a number attached to the absolute value, okay, you guys have an example we're going to do in a second. But if there is a number attached to the absolute value, you're going to divide both sides of the equation by that number. And now we'll look at an example. So if there is a number attached means it's like glued right to the bars. It's like stuck right next to them. Okay, so this example, do you guys already have that on your on your notes? Okay. So that's an example where the absolute value is not by itself. Okay? I don't care if there's stuff inside the bars, that's fine. But when I say I want the absolute value by itself, I don't want anything else next to the bars on the outside. Right? So this is a problem. Okay, we don't want that 3 there. And that 3 is attached to the bars. It's right up next to them. So what did the directions say to do under the if? If you have a number attached right next to the bars, how do we get rid of it? Yeah?
Divide on both sides with the equal sign.
Yeah, we're going to divide both sides by what?
3.
Yeah, divide both sides of the equation by that number. What number? In our problem, it's 3. So what that does is 3 divided by 3 gives you how much?
1.
1. So that's gone. Now what we've done is you've got the absolute value by itself. Okay, that's what you always want to start with. Most problems that I give you are already going to have the absolute value by itself. You may have 1, maybe 2, where I do something like we just did here. Okay, most problems, they're already going to start out for you by itself. And what's 6 divided by 3? 2. Now we're ready to solve that problem. Okay, I'm not going to go through solving it yet, okay, because I'm going to give you the directions. But any questions on how to, at least if you've got a number attached, how to get rid of that? That would be your first step. Okay, let's look at this one. Okay, don't write it down yet. But is there a number attached to the outside of the bars?
No.
No, you don't. So you don't have to do that step here. That step was already done for you. You don't have to worry. Okay. All right. So there's one other kind of thing that can happen. Right? You could have something where there's a number attached and there's a number that's also added and subtracted outside the bars. So there's actually 2 things outside the bars. Okay? So if you have a number attached, like we did before, and there's another number that's added or subtracted outside the bars.
Why is attached in all caps?
Just so you remember, attached. You don't have to write it in all caps. Okay? In this case, we have 2 things we have to fix. Okay? And we're going to do an example of this in a second. First thing we're going to do is get rid of the number that's been added or subtracted by doing the opposite operation on both sides. Remember, opposite operation means if you see plus, you do minus. If you see minus, you do plus. So this part that I just underlined, that's like the extra step in this part. The last thing is what you just did before. Divide both sides of the equation by the number that's attached to the bars. Okay, this part we just did up above. So that part's the same. So I'll give you guys a second to copy that down. Do you guys already also have the example already? You got it already, okay.
Yeah.
So remember, the goal is what I just put that red box around. You want that alone. How many numbers are outside of that red box on the left side?
Which sides are left?
On the left, the side with the red box. How many numbers are outside that red box? Yeah, James?
2.
2. There's a 6 and there's a negative 14. Both of those are no good. We can't have those there. Okay? So the first thing you're going to deal with is that by doing the opposite operation. And then the second thing you're going to deal with is that. So the second thing, you guys already did something like that right here. The second thing is just doing this again. But the first thing is getting rid of that negative 14. So how would I take that negative 14 and put it on the other side?
Add
Yeah, add how much?
14.
Yep. So for now, you could almost do something like this. If you put a box around that and then I just like fill it in. I don't care what's inside the bars right now. I don't even need to see what's inside. All I need to do for now is get rid of that negative 14 and get rid of that 6. I'll care what's inside the bars later, okay, but not now. So plus 14, plus 14. That's gone. So now I just have a 6 attached to the bars. I'm going to write what was in the bars just because we don't want to forget what was in there, but we don't really care about it yet. And what's 10 plus 14?
24.
24, good. Okay, so now we got rid of one of the things we didn't want. What's the other thing that I don't want?
This is
I don't want the 6, okay? So how do I get rid of the number that's attached? And this is what we did in the first part.
Divide.
Yep, by
6.
6, divide by 6, that's gone. Now you've done exactly what you wanted to do. A minus 7 in the bars is all by itself on the left. And this is going to give me 4. Okay. So that's as bad as it can get for having extra stuff outside the bars. The number there and a number there. Most of the time you're not going to have to do one that complicated. All right. So now, if you look at this, or look at this, is x by itself?
No.
No. We haven't got x by itself yet, or a, whatever the letter is. This is the last step. Now I'm going to show you how you get rid of the bars and get the answer. Okay? So, after you've done step 1 and made sure that the absolute value is all by itself, step 2 is to get rid of the bars. Okay? Eliminate the bars. And this is how you do it. You're going to take your original problem and split it into 2. So this is where most of the time you're going to get 2 answers from.
What is the underlined word?
Splitting.
What?
Splitting. You're going to
Okay.
split the equation into 2. Or separate it, or break it up, however you want to write it. You're going to break it into 2 equations. Now, if you want to write that again, you can, but you already wrote this in step 1 right here. You can't do step 2 until you do step 1. You've got to have the bars by themselves. So this is step 1. So you don't really have to write that part again if you don't want. Okay, so we've got a little diagram on your notes that's going to kind of show you how we do it. When we split it up into 2 problems, both of them are going to be written without the bars. So you got a little space on the diagram, you could put it right on your spot where it is on mine. Okay, so when we split it up, the bars are gone. The bars are totally gone now. Now, one of the equations is going to be the original. Literally, all you're going to do is write the original, but the bars are gone.
You can write that.
As long as you know how to solve, as long as you can remember it, that's fine. Right, so what would that mean, the original problem without any bars? Let me scroll back up to what we did on one of them. That's one of the equations you would write down. That's the original problem. All I did was take away the bars. A minus 7 equals 4. Now the other equation, you're going to do the same thing. You're going to get rid of the bars, but the extra step is you have to change the number after the equal sign to its opposite. Its opposite. So change the number after the equal sign to its opposite. So opposite means if the number after the equal sign was a 2, make it a negative 2. If it was a negative 12, make it a positive 12. All right? So let me show you how that one would look. So no bars, change the number to its opposite. Okay? So if I was going to do that, and I'm going to scroll right back down. If I was going to do that on this one, no bars. That's the first one. Now the second one, no bars, change that number to its opposite. That would be the other equation that I need to solve. Okay, so they're two separate equations. And then once you do that, now you just solve it. What's nice is the two equations that you solve, you're going to use exactly the same steps in each one. So it's going to speed things up a little bit. Because these two equations are going to look almost identical. It's just one number is going to be a little different. But other than that, you're going to use exactly the same steps to solve each one of them. Okay, I've said this to you guys a few times now. And actually, I wrote it down earlier. But almost always, you're going to have two answers. I'll show you what happens when you don't. Okay, and this thing that I have the asterisk next to, I think you guys already have that printed on your notes. Does it say on your notes, answers are connected by the word and?
Yeah.
Okay, so you don't have to write that handwritten part down. You already have it. Okay, so just copy down up to right there. Okay, so that's kind of the front of the guided notes for today. That gives you the steps. And now on the back, we'll do some examples. Okay, does anyone else still need to copy anything from steps 1, 2, or 3?
No.
Yep.
Almost done.
Step 3?
Yeah.
So now if you get stuck, okay, when you're going through, or if I call on you today, just look back at the steps.
Okay.
You don't have to have them memorized yet, okay? And even on Friday, you don't. Remember, you're gonna get a reference sheet, and you can write anything you want on that. I mean, I have some examples that are already on it, but you can add to it, okay? Whatever you want to add. All right, so let's solve this one. And they also want us to graph it. Okay, that's what that number line is going to be for. Okay? Graphing it is super easy. I don't even really have to explain much with that. It's really, really simple. All right, so what do I want to check here when you're solving an absolute value equation? What's the first thing you always want to make sure? James?
there's no brackets in the lines.
We don't want to get rid of the lines yet. There's something we got to check for first. What do we have to make sure? It said ensure something.
To make sure there's no numbers like next to the absolute.
Yeah, we don't care what's inside. We just don't want to have anything attached in front right there or anything added or subtracted right there. Do we have anything outside the bars? No, then we're good. Okay? That's on the other side.
Yeah.
So yeah, we're talking about just on the left. There's nothing outside the bars, so we're good to go. So what I usually do is this. I just draw 2 lines to split it up. Now you don't have a ton of room in the box, so you'll have enough room, but you don't want to draw it too big. And now we got to write the 2 equations. What's my first equation? What does it say? My first equation, actually I just got to do one thing to get the first equation. Yep.
Copy the same thing. To copy the original.
But
Have a negative.
one more thing. It's the original, but you do take out something.
The I don't know what they're called. Brackets. Not brackets. The signs, the value signs.
Yeah, take out the absolute values. Okay? Copy the original, but just take away the bars. Just like this. That's one of the problems we're now going to solve in a minute. Let's do the other one first, though. What's the other equation I'm going to set up? For this one, I got to do 2 things. I got to do the same thing I did here, and one extra step.
Change it to the opposite.
All right, change it to the opposite sign. So what's this equation going to be, Steven? Joe?
X plus 1 equals -3.
Yeah. So it's the same as the original. I just took away the bars, but I made the number on the other side negative. And now we solve each equation, and the steps are exactly the same. It's the same steps on the left, same steps on the right. Yeah. Yeah, just sign up. So to get x by itself, how about Adriana? When I want to get x by itself here, how would I move this +1 to the other side? Subtract. Yeah, wait, what did you say? Subtract how much? Yeah, exactly. We're going to subtract 1, subtract 1. +1 minus 1 is gone. This one's easy. That's it. One step.
Do you need to do the 2?
Well, we have to write down what is x here. X is 2. Now, when we solve the other one, we're going to get a totally different answer. So we got to have both. So x could be 2. And how are we going to get x by itself on the right? It's exactly the same step you did on the left. +1 minus 1, gone. What's -3 minus 1, Blake?
-4.
-4. And there are your 2 answers. Let's make sure they work. If you plug in 2 for x, what's 2 plus 1?
3.
3. And what's the absolute value of 3?
3.
3.
Because it's not negative.
Now, what about, let's try -4. What's -4 plus 1?
5.
That's 4 plus 1.
Yep. But don't the brackets make it not negative?
Just what's -4 plus 1? Do what's inside first.
3.
Negative 3. And now what's the absolute value of -3?
3.
3. So that answer also works. Okay? So if you want to check it, you can. You plug it back in and see if it works. Now what's the other thing they said to do? Graph it. All you have to do to graph it is put a dot on the 2 answers. So you might have to number your own number line. Maybe on the test some of them might be numbered for you. Just go by 2s. You don't have to number everything, just number enough to do it. Put a dot on 2. So what we're doing is we're like shading in all the numbers that are answers. So we only put a dot on the 2 and a dot on the -4. That's it. Those are the only two numbers that are answers to this problem. Now, if you've done something in another class where you actually like shade like this and put an arrow, has anybody done stuff like that? That's not this. That's like something similar we're gonna do later on. Okay, so for this one, you just have to shade two dots. Okay. Any questions on that one? So the simpler this thing is, the quicker you'll be able to solve it. The more complicated it is inside, the longer it takes to solve. Right? So that one's a little bit more complicated, but let's try that one. All right. How about Kayla? What's the first thing, no matter what absolute value equation we're solving, we always have to check for?
Make sure there's nothing outside the bracket.
The bars. Yeah, perfect. Make sure there's nothing else outside these absolute value bars. Is there anything outside?
No.
No. It's just 2x plus 4, absolute value, already by itself. So what are we ready to do with this one right away?
Put the lines.
Yep. We're ready to separate it into two different problems that we're going to solve. Okay. What's one of the problems that we're going to put there to solve? Yeah.
2x plus 4 equals 8.
Perfect. She just copied the same problem but took away the bars. So we'll do that one. And let's write down the other one we have to solve. What's going to be, Olivia?
2x plus 4 equals negative 8.
Yep. 2x plus 4 equals 8. 2x plus 4 equals negative 8. And now both of these are two steps. So how about, Gianna, what's my first step to get x by itself on the left?
You have to subtract 4 on each side.
Yep, perfect. I'm going to subtract 4 from each side. That leaves me with 2x on the left. And what's 8 minus 4? Mackenzie?
Negative 4.
Or
just 4.
Just 4, yeah. Let's go with that. So 8 minus 4 gives me just 4. And my last step. Yeah, divide by 2. Perfect. There you go. So what is, Princess, what's 4 divided by 2? 2. Yep. There we go. So x equals 2. And if you stop there, I give you half. You got one answer. Now the second answer, do the same steps again. How about, Blake, what's my first step on the next problem?
You gotta subtract 4.
Just like we did over here.
Yeah.
And that gives me 2x. What's negative 8 minus 4?
Negative 12.
Negative 12, good. And how about, Aileen, what's my last step here?
Divide by 2.
Yep, that's it. Divide by 2. Divide by 2. And we get x equals, what's half of negative 12? Negative 6. Yep. Now, I just have to see, did it say solve and graph or just solve? Just solve?
But
Okay.
it didn't say anything.
Oh, that one didn't say anything. Do you guys have a graph on yours?
Yeah.
Okay. So let's graph it. So once you solve it, I mean, graphing it, that's the really easy part. You could go by ones if you wanted. I'm just going to go by twos again. Just number as much as you really need to. You don't have to number a lot. Where am I going to put my two dots this time? James?
1, negative 6.
Yep.
2.
That's it. So all you're doing is really shading the number line on two spots. It's not even really shading, you're just putting two dots. Okay. Any question on that one? Yeah. Yeah, just say no. All right. So 1C, I'm going to give you guys a couple minutes. It's actually a simple one to try on your own. Okay. Absolute value of 3x equals 21. Okay, so take maybe a minute or two And the directions are solve and graph. Okay, when you number your number line this time, you might want to go by threes, because your number line might not be big enough. I mean, you could go by fours too, or the thing is, you're going to be in between marks if you do that. But that's okay. I think you got enough room to go by. I think to go by. Dang, you can probably get away with twos or threes. Either one will probably be fine.
Wait, I have a question.
Yeah.
Do you still have to like put two equations?
Yeah. Anytime you have absolute value bars, you always have to split it into
This is
two.
giving me a lot more trouble than the other ones did.
So you're gonna do this one the same way. Separate it into two equations and follow the steps for each equation. Okay, first question. Is the absolute value by itself?
Yeah.
Yes. Okay. That's one where it's not by itself. Okay, we're gonna do that next. This one, by itself. So split it up. What's gonna be my first equation? Olivia?
3x equals 21.
Yep. So 3x equals 21. She wrote down the original problem, just no bars. And what's gonna be my second one? Yep.
3x equals negative 21.
Yep. So it's the same problem, no bars, but then she made the number on the other side negative. What's going to be this one step to solve both of these? Just one step. Yeah.
All I have to do is find the one that I was right.
Yep. And what are you going to divide by? Perfect. So Julia told us divide by 3. Divide by 3. If you want, just do it over here at the same time. And 21 divided by 3 when I walked around, most people got 7. And this is negative 21 divided by 3. Negative 7. Okay, now to graph it, what I would probably do is just go like this. Put 0, put negative 7, positive 7. That's it. I mean, if you want to go by 2s or 3s, you can, but
I just went by threes.
you could.
I went by 2.
If you go by 2s or 3s, like if you go by 2s, then your dot is going to be in the middle of 6 and 8.
I just did
Be right in the middle.
Yeah, one flat.
Right. But with the graphing, there's a little bit of flexibility. There's a lot of ways you can do it. Okay, so any questions on the type, which most of them on the test are going to be like that, where you have the absolute value by itself?
I'm not gonna
What's that?
not
All right, let's look at this one. So this is our second to last problem. There we go. All right. First thing we got to check for is the absolute value by itself.
9.
No, it's not by itself. What's preventing it from being by itself?
The 2.
The 2. That's a number that's attached. So how am I going to get rid of that 2?
divide.
Yep, what do you divide by?
You divide by itself.
Yep, divide by that number.
2.
And what happens when you do 2 divided by 2?
It cancels out.
That cancels out. Gone? Gone. Now, on the left, it's exactly what you want. Absolute value of 3y plus 5 equals
2.
2. Now it's just like the other examples. Now we'll solve it from there. Okay, so once we get the absolute value by itself, what is your next step?
You split the equations.
Split it up. Blake, can you give me one of my equations?
3y plus 5 equals 2.
Perfect. 3y plus 5 equals 2. And my other equation, 3y plus 5 equals
Negative 2.
-2. Okay, both of these are going to have 2 steps. Okay. What's my first step in both of them to get y alone? Yeah, Mackenzie?
D minus 5 equals x.
Yeah, -5 minus 5. That gives me 3y. What's 2 take away 5?
3, negative 3.
Yep, -3. Divide by 3, divide by 3. And y equals
-1.
-1. Okay, so there's my first one. My second one, what's my first step? Yeah,
Do you do the -5
yeah. And where else?
under the 2?
Do the -2. +5 minus 5 is gone. What's -2 minus 5? Yeah, -7. Okay. And now my last step, same as I did over here, divide by 3. So divide by 3, divide by 3, and that's my answer. -7/3. Now, when I graph that, I'm probably going to use a calculator to help me, so I can change it to a decimal. All right, let's make our number line. Let's go 0, 1, 2, 3, 4, -1, -2, -3. I don't even think I need to go all the way to 4. Okay, the first dot, that's easy, -1. Now, the second dot, okay, to figure out where that's going to be, take -7 divided by 3, -2.3. So where's that going to be? About -2.3. Yeah, where am I going to put the dot for that? Yeah, right, just a little bit to the left, not quite in the middle. The middle would be -2.5. So it's a little bit less than that. It's like -2.3. Okay, I'm not going to take points off if you had it, you know, around that area. Now, if you put it like over here, that wouldn't be right. That's too far over. Okay, right about there. Okay. Any questions on that one? Okay, so that was a solve. Actually, it didn't say graph, but you guys. Actually, I had the graph. I don't think you had the graph in your notes for that one. So you didn't have to worry. If you didn't graph it, that one was okay. Okay, let's try this one. Now, before we do it, I just want to ask one thing, and I want to keep this in mind. When you take the absolute value of a number, it always comes out what? Positive. Okay, keep that in mind. Okay, is the absolute value by itself here? No. What is wrong with that? Yeah.
The +5.
We've got a +5 outside the bars. We don't want the +5. Now, is the +5 right up against the bars, like attached to it? No. So we got to use the opposite operation of +5, which is subtract how much? 5. Subtract 5, subtract 5. +5 minus 5 is gone. And Lucas, what's on the left side now?
Left side, just x minus 1.
Just the x minus 1, which is exactly what you want. And what's 2 minus 5? -3. Now, this is where some people make a mistake. They go like this. Okay? Don't write this part down. They say x minus 1 equals -3. And then they say x minus 1 equals +3. And then they add 1 to each side. And they say, oh, x is -2. And then they say x is 4. But let's check 4. Like if you did all this work, let's see what happens. What's 4 minus 1? 3. All right. Now, what's the absolute value of 3? 3. And what's 3 plus 5?
8.
Not 2. So that one didn't work. Let's try -2. What's -2 take away 1? -3. And what's the absolute value of -3?
3.
And then 3 plus 5 again is not 2. So this work wasn't right. What's wrong right here that you can pretty much just stop?
Brackets.
There's something different about that.
Can you make the
Negative.
-1 positive?
It's negative, right?
Sorry, Joe.
The problem here is you have an absolute value equal to a negative. And I just asked you guys, whenever you take absolute value, it always comes out what?
Positive.
Will it ever come out negative? No. So this one is no solution. Okay, so if you end up with an absolute value equal to a negative,
Wait, what?
you can't solve it. Okay? I showed you what happens if you try. It doesn't work. Now, what if you had this? -2, absolute value of x plus 1 equals -6. And you say, oh, Mr. Hager said if it's equal to a negative, you can't solve it.
No, because you're dividing by a negative and that's a -6, so it would be positive.
Right. Okay? What I'm saying is if the absolute value is by itself and it's equal to a negative, you can't solve it. Is the absolute value by itself in this one? No. So because the absolute value isn't by itself, your first step is to do this. And now that's gone. And then what happens when you do -6 divided by -2? +3. Now that's a problem you can solve. So get the absolute value by itself and check and see. Okay, if it's negative, I'm done. No solution. Guarantee this will be on the test. Okay, and when I put it, people will split it into 2 problems and they'll just solve it and they'll just circle each answer like I did.
Wait, so then what's wrong with? Oh. right,
Because the
it's
answers, we
negative.
checked them and they didn't work. And the reason they don't work is because of that negative right there. If you got rid of it, now it's perfect. Those answers that whatever I had before, they would work now. But not with the negative. That's a no solution. Okay, so that's the really, like, rare case where you don't get 2 solutions. Yeah.
So, as soon as there's, after you've done and reduced everything, if it's equal, it says equal to a negative, you don't do anything else?
Yep, after you do step 1, if it's equal to a negative, you just write no solution. Okay, no solution. All right, so a couple reminders. I'll give you guys the homework sheet tomorrow. Okay, we're gonna have a review day. Okay, we will probably, like throughout the year, we'll practice a couple MCAS questions. But the review day is not tomorrow, it's Thursday. The MCAS questions are just to kind of get you guys to start thinking a little bit about these kinds of problems. You know what? Maybe we'll do an MCAS question, we'll see. Right? If we do an MCAS question, it's quick. It takes like 10-15 minutes, and then the whole rest of the day will still be reviewed. Okay? But I would try to find an MCAS question that's on what we learned this week. Okay? Not like a random question. Okay? Wednesday is the last day of new material this week. Okay? Remember, test on Friday and progress reports close Friday. So if there's anything you still need to make up, it's got to be turned in by